Okay, so let's try to tackle this problem. This is under the topic of greenhouse gases. Okay, so for this question, a planet has an albedo of 0.30. A simplified energy balance for the planet is shown here in this diagram. Okay, the question is asking, what is the intensity radiated by the surface of the planet? Okay, so immediately just by looking, okay, we can see that we are referring to the amount that will be radiated, okay, with reference to this particular part of my diagram, the surface in particular. Okay, so let's first start or try to at least label and try to make sense of the numbers that we have. Okay, because we have an albedo of 0.30, okay, going back to the definition of what albedo is. Okay, this is actually going to be 30, okay, 30 or 30%, okay, gets reflected. Okay, it's the surface reflecting 30 or 0.30. That's the value for albedo. So in this area here, notice the units. Okay, I could say that 30 watts per square meter gets reflected at this particular region. Okay, however, note as well that there is an incoming intensity of 100 here. Okay, so if 30 got reflected but 100 came in, that means that in this particular region there should be 100 minus 30, which is 70, okay, watts per square meter in this particular part, which goes to the surface of the planet. Okay, now it's very tempting to just go ahead and circle 70, but if you really analyze the diagram, notice that you have an arrow here that kind of looks like it's going back to the surface, so you have to take that into account. And then the value given here is 60. So the question is, what is the amount in this particular region? Okay, well, because there's 70 that reaches the surface, and then there's also for some reason a 60, okay, that is pointing that is going to this region. That means in this particular place there should be a total of 70 plus 60, so 130 watts per square meter in this part. Okay, and then again, the reason for that is because you have the 70 coming in here, and then you have a label here of the 60 that is going or returning, if you will, to the surface of the planet. Okay, so what else can we make sense out of this? Okay, well, going back to our basic knowledge, okay, in this area or in this region, okay, because the 30 already left, if 70 came in, okay, ideally this 70 should also get released into the atmosphere, or sorry, it should be released eventually. Okay, 70 comes in, 70 should also come out. However, that is not exactly what will happen, because again you have the 60 in this area. Okay, so what does this part mean? This part means that there is an intensity that gets trapped in the surface of the planet again. Okay, it gets trapped. Notice that there's an atmosphere here, and going back to our class discussion, okay, that when you have gases, okay, gases that get trapped in your atmosphere, okay, not all 100% does not leave the atmosphere. Okay, there's a significant amount that gets trapped, hence allowing for the warming or the warmer atmosphere. Okay, we have what we call the enhanced greenhouse effect, if you recall our discussion. Okay, that has to do because of the atmosphere. All right, so if 60 returned but 70 must go out, okay, that means that really there's only 10 watts per square meter that's exiting in this area. Okay, so again, just to kind of reiterate, okay, 30%, okay, that's given, that was reflected, which means that in this region only 70 got absorbed. Okay, but on top of this you also have the 60 coming back. Okay, because again this is a process, this is a cycle. The 60 that was trapped, so in total here it's actually a total amount of 70 plus 60, so that's 130. Okay, now 10% only goes out, because ideally 70 comes in, 70 goes out, but because of the 60 that gets or returns or is trapped, you only have 10 going out. Okay, all right, so anyway, so now going to the question. So hopefully we've analyzed this diagram enough. what is the intensity radiated by the surface of the planet? Okay, so what that means is we're looking at, okay, what will be the total amount that the surface will radiate, okay? If I just put 70 as my answer, that's not going to be correct because that's not the total amount, okay? It's not only going to radiate 70. It's going to radiate 70 plus the 60 that was trapped again within the atmosphere. So in total, the amount that gets reflected, regardless of whether some will be trapped again or some will escape, okay, you're just talking about the amount here, the starting amount that will get radiated would be 70 plus 60, which is 130. So the answer should be letter D.